Imagine you're floating through space, looking down at our solar system. Four small rocky worlds, Mercury, Venus, Earth, and Mars, sit closest to the Sun, while four enormous gas giants, Jupiter, Saturn, Uranus, and Neptune, dominate the outer reaches. But why? Why are the inner planets small and metallic, while the outer planets are huge and filled with gas? This isn't a coincidence. There's a powerful scientific reason behind this cosmic pattern. Join me as we travel back in time, to the very birth of our solar system, to uncover the truth. Over 4.6 billion years ago, our solar system was nothing more than a giant cloud of gas and dust drifting through space. Then something changed. A distant shockwave, possibly from an exploding star, sent ripples through the cloud, collapsing it under its own gravity. At the center, matter pulled together, growing hotter and hotter, until, boom, the sun was born. But the story doesn't end there. The planets in our solar system are thought to have formed from the rotating disk of dust and gas that gave rise to the sun. This disk, known as the solar nebula, was primarily composed of hydrogen and helium, with smaller amounts of other elements. As the nebula swirled around the developing sun, it carried a certain amount of angular momentum. Within this spinning cloud, tiny particles began to cluster together under the force of gravity. Over millions of years, these particles merged into larger chunks, eventually forming approximately 1 billion planetesimals, each about 1,000 meters in diameter. As these planetesimals continued to collide and coalesce, they grew into even larger bodies, roughly the size and mass of the Moon, known as protoplanets. This gradual buildup of material through collisions and mergers is a process called accretion. As the sun ignited, the leftover material began swirling around it, spinning, colliding, sticking together, slowly forming the planets we see today. But depending on where a planet formed, it became either a rocky world or a gas giant. Here's why. The first four planets are small, dense, and made of rock and metal, and last four planets are huge and made of gases. But why? The first reason is heat. Near the sun, temperatures were so extreme, like 2000 Kelvin, that light gases like hydrogen and helium couldn't stick around. They were blasted away by the sun's radiation. Only materials with extremely high melting points could remain solid, while everything else would have vaporized. As a result, inner solar system objects primarily consist of elements like iron, silicon, magnesium, sulfur, aluminum, calcium, and nickel, many of which bonded with oxygen to form compounds. Since there were few other elements available in solid form, the inner planets were built from these materials. Compared to the outer planets, the inner planets are significantly smaller, which means they have weaker gravity and were unable to attract and retain large amounts of gas in their atmospheres. The second reason is solar winds. In the early days, the young sun unleashed violent solar winds, stripping away any lingering gases. The result? Compact, solid worlds with thin atmospheres. But move further out, and the story changes. Farther from the sun, beyond the asteroid belt, a new world of possibilities opened up. Here's what changed. First, it was cold enough for gases to stay. Unlike the inner planets, the outer regions were much cooler, and their temperature is 50 Kelvin. This allowed elements like water, methane, and ammonia to freeze into solid ice instead of vaporizing, allowing the formation of the giant planets. Second, icy cores became giant planets. These icy particles clumped together, forming massive cores. And once these cores grew large enough, something incredible happened. They captured massive atmospheres. With their huge size and gravity, these planets pulled in and held onto enormous amounts of hydrogen and helium, the most abundant elements in the universe. That's why Jupiter, Saturn, Uranus, and Neptune are huge and rocky. They became giants, wrapped in thick, swirling atmospheres. It was all about location, gravity, and the sun's influence. But what if things had been different? Imagine a solar system where the inner planets were gas giants and the outer planets were small and rocky. Sounds impossible, right? But in distant star systems, we've actually found planets that break the rules. Some stars have hot gas giants that orbit dangerously close to their sun. Others have super rocky planets, larger than anything in our solar system. So, why did our planets form the way they did? It all comes down to the sun's heat, the materials available, and the laws of physics. And that's what makes our solar system so special. Our solar system is a masterpiece of cosmic forces, shaped by temperature, gravity, and time. Now, the next time you look up at the night sky, you'll know exactly why our planets are the way they are. If you enjoyed this journey through space, don't forget to like, subscribe, and hit the bell icon so you never miss a video from Science Interval. And before you go, if you're interested, then check out this next video. Thanks for watching. See you in the next one.